Today we're going to take a look at the composition of inverse trig functions. Now remember, a composition is when you have a function within a function. We learned about this in Chapter 1, looking at f of g of x. So here's an example. We've got a tangent that's composed with an inverse tangent. So I'm going to remind you that this statement here, arctan of -5, that means that the tangent of some angle is equal to -5. So this is what this means up here, but then we're being asked to find the tangent of that. So it's a little redundant. What's happening is we're being asked to find the tangent of the angle whose tangent is -5. They're already telling us what the tangent is. Another way of thinking about this is we have inverse functions, tan and arctan are inverses, so they in a sense undo each other. So if we wanted to find the tangent of the inverse tan of a value, it would just be equal to that value. Now we do have to be careful with these types of problems. Here again we've got cosine of the inverse cos of 3. So this here is saying that there's an angle whose cosine is equal to 3. But you want to keep in mind that the range of cosine is just -1 to 1. There is no angle such that the cosine is equal to 3. So this, in fact, is undefined. So what you want to be careful of is making sure that whatever value you're given is in the range of your function. Okay, now we're going to switch things up a little bit, where we've got the inverse on the outside. So we're putting the sine function within an inverse function. Now you would expect the same thing to happen here, that we've got sine and inverse sine, so they would undo each other in a sense, and that we'd be left with the angle 5 pi over 3. That is almost true. What we have to take into consideration is the range of arc sine. We know that the range of arc sine is -pi over 2 to pi over 2. Now 5 pi over 3 would be in the 4th quadrant, so we're looking at this angle that wraps around here. That's 5 pi over 3, but we need that angle to be between -pi over 2 and pi over 2. So that would be this angle right here, which is just -pi over 3. So the arc sine of the sine of 5 pi over 3 is equal to -pi over 3. So just to recap quickly here, if you're taking the arc sine of sine, the answer will have to do with this angle here. But you need to find a coterminal angle that is between -pi over 2 and pi over 2, because that is the range of arc sine. Now in this next example, we're going to be combining different functions. So not just tan and arctan or cos and arccos, we've got tan and arccos. So first what we're going to do is determine in what quadrant this angle must lie. Well, looking here, 2/3 is a positive number. Cosine is positive in the 1st and 4th quadrants. So I'm going to rule out quadrant 2 and quadrant 3. We also know that the domain, or the range of arccos, is 0 to pi, right? That's 0 to 180, so that would be quadrant 1 and quadrant 2. So that rules out quadrant 4. So our angle must be in the 1st quadrant. And what we're going to do is we're going to create a nice little right triangle here, and we're going to label it according to the information that they gave us. Now this means that there's an angle whose cosine is 2/3. And remember, the ratio for cosine is adjacent over hypotenuse. So adjacent would be 2, the hypotenuse would be 3, and then we'll use the Pythagorean theorem to find the third side. So what do we have? We've got a squared plus 4 equals 9. A squared must be 5, so a is positive 5. We're going to reject the negative because we're talking about a length. So the third side is radical 5, and we're looking for the tangent of that angle. And tangent we know is opposite over adjacent, so that would be radical 5 over 2. All right, one more example and then we'll look at our summary. Here we've got mixed functions, cosine with arc sine. We've got a negative value, so let's see where sine is negative. Sine is negative in the third and fourth quadrants, so we're ruling out 1 and 2. And the range is negative 90 to 90. So that's negative 90 to 90, so that rules out quadrant 3, so this is gone. So our angle must be in the fourth quadrant. We'll set up our triangle, and here we've got that the sine of an angle is negative 3 over 5. Now the next thing that we have to decide is where does the negative go? Does the negative go with the 3 or would it go with the 5? And the answer is really within the ratio. Remember, this is opposite over hypotenuse. And the hypotenuse is our radius, and that always has to be positive. So this will be positive 5, and opposite will be negative 3. Now the length is 3, but we're going in a negative direction. We can use the Pythagorean Theorem to find the third side, or we can recognize that this would be a 3, 4, 5 triangle. And the cosine of that angle, right, that's adjacent over hypotenuse, would be 4 over 5. And that's it. So in summary, if you are working with the same function, here I'm using the example of sine, where we've got sine of the arc sine or arc sine of the sine, you're really thinking about those functions undoing each other. So here we'd be left with the ratio, and here we'd be left with the angle. You just have to be sure with the first that this value is within the range of sine, and with the second one, you need to make sure that your angle is within the range of arc sine. Now, if you're looking at mixed functions, so that would be maybe the sine of arctan, you've got these 4 steps here. First, you're determining the quadrant in which your angle must lie. You're using 2 pieces of information. That's the range of your inverse function, as well as the sine of the ratio that you're given. You're going to draw your right triangle in that quadrant and label the sides. You're going to solve for the missing side and then evaluate that trig function using your triangle.